Hello everyone, I am Adrenaline the Bazuka Prophet. Now, in this particular video, I'm not going to waste time, right? Now, for students that are preparing for Cambridge A-level exam, IB, AP, and any other exams that are very important at this time of the year, I'm going to be solving for you a short examination questions, and I will explain. Now, the heading of this question is Bohr's transition, and the question is calculate the wavelength and the energy associated with a jump of an electron from the second energy level to the third energy level in a hydrogen atom. Calculate the energy in units of joule per transition and kilojoule per mole of transition. This question is very easy, so I'm going to be breaking down for you quickly. Now, first of all, you should understand that wave number is simply equal to 1 over the wavelength is equal to the Rydberg constant 1 over n1 square minus 1 over n2 square. Now, from this question now, we're told that there was a jump of the electron from the second energy level to the third energy level, meaning my n1 is 2 and my n2 is 3. It's actually very simple. So I come here. 1 over the wavelength is equal to, let me use 109,678, right? 1 over 2 square minus 1 over 3 square. Now I can decide to use, this is a constant. It is called the Rydberg constant of hydrogen. Now it is a constant. I can use this, or I can also use 1.096 times 10 raised to the power 1, 2, 3, 4, 5. So let us go quickly. Now, the best way I often teach my students to do this is to basically just use your calculator to do it once. Use a Casio calculator. Now I come here to say 109,678, okay, multiply by bracket. Here is 1, 4, okay, minus 1, then 9, those bracket, okay. So I am having my value here to be 1 over wavelength is equal to 15,233.055, then let's say 6 here. So what do I do next? To get for the wavelength only, it will be 1 over this answer I got here. So 1 divided by the answer. So I got it to be equal to 6.5647 times 10 raised to the power of 1, 2, 3, 4, 5. -5, right, per centimeter. Now, if I'm to leave my answer, right, if I'm to leave my answer in nanometers, I will use the shortcut that says 6.5647 times 10 raised to the power minus 5 times 10 raised to the power 7. This is the shortcut to convert from centimeter. Okay, here will give me in centimeter now. Here was in per centimeter. To convert my centimeter straight down to nanometers, I will just use the shortcut 10 raised to the power 7, which should now be equal to 656.5. Okay, let me just say nanometer, right? But the question also says I should calculate for my energy in joule, right, per transition. The formula is energy is equal to hc over the wavelength, which is equal to the h is Planck constant, which is 6.63 times 10 to the power minus 34 times 10 times 3 times 10 raised to the power 8 meter per second over, remember my wavelength now will now be in meters, so it will be 656 times 10 raised to the power negative 9 meters. Remember, nanometers. So let us see what we can do here. 6.6 4 656. I have my value here to be 3.03 times 10 raised to the power of negative 19 joules. Joules. So this is my joules per transition. The next one now says, what do I do? I'll first of all get my answer in joule per mole. Joule per mole. Because the answer says calculate your answer again in kilojoule per mole per transition. So we have to get our answer first of all in joule per mole. Simple. In doing so, we'll simply just multiply 3.03 times 10 raised to the power minus 9. We multiply by the Avogadro's number, right? Which is 6.02 times 10 raised to the power what now? 23, right? Now to get our answer, here will give me what? Times 6.02 23. So I have my answer to be 182.527.134, right? Here is in joule per mole. Now to get my answer now in kilojoule is to divide by 1000, which will now be 182.527 kilojoule per mole of the transition. That is simply just the final answer. That is simply just the final answer. Look at the steps here. This is the energy, and the energy. But the units is what differ. First, we got our energy in joule per transition. Next is joule per mole. And lastly, in kilojoule per mole of the transition. This is the end of this video. Do well to like, share, and subscribe. Thank you, and God bless you.